This next set, you can solve the system of equations using any method. So you could use the elimination method, or you can use the substitution method, or you can use Cramer's rule, or the inverse matrice rule. All of those will work, but the most efficient way to solve these is going to be using the reduced row echelon form in your calculator. And to do this, you'll type in RREF, open your parenthesis, and then create a box of the matrix C, which is the button right next to the 9, and it'll be the center option. In this case, we have 2 rows and 3 columns. And you're going to type in the numbers like this: 5, -1, 4, 2, 13, 3. And you'll close your parenthesis outside the matrix C. What your calculator is going to give you is the format of a reduced row echelon form, which should look something like this, with some numbers over on this other side. If it does, that means that there's a solution. And these 2 numbers will be that solution. It'll be the ordered pair. And the x value is the first, because this is your x column, this is your y column, and if you had this is your a's and b's, or whatever it may be. And so 1, 2 is my solution. So let's go to the next one. Same idea. I'm going to go ahead and use the calculator reduced row echelon form because it's the most efficient way to do it. So like if I was on a ACT or SAT and I was needing to solve a system of equations, I would go to the reduced row echelon form. And so again, -5, 5, -1, -4, -2, 18, -1. And then close it. And that's going to give me my matrix C, which is going to look like 1, 0, 0, 1. And this time, it gave me some fractions. And it gives me -4/3. And the other one is -17/6. And think about, like, if we were actually having to do this by hand, that would mean I would have had to plug in one of those 2 fractions into the other equation to solve. It makes it so much easier using this reduced row echelon form in the calculator to help us do these. And so the ordered pair, again, comes from this last column. That last column is -4/3, comma, -17/16. And that's the answer. Okay, again, I'm going into reduced row echelon form. Now on this one, if you would have noticed that every single one of these times -1 is the following row, it gives you a hint this is the infinitely many solutions. But if you don't know that, or if it doesn't work all the way through, so let's say it works for the first 2, the x's and the y's, but doesn't work for the other, then that would be a no solution. Or if you don't notice it at all, you can go ahead and go to the reduced row echelon form. Again, that same process, -1, -3, -6, 1, 3, 6. And the output this time is going to be a little bit different the way it gives us the answer. Oops, that doesn't need to be written again. And this time the answer has a row that has all zeros. So the first row is like this, and the second row is 0, 0, 0. This row is how I know if it's infinitely many solutions. If it's all zeros, it's infinitely many solutions. If I would have had this and some number, then that would be no solution. So if you had the first several columns being 0 and the last thing being a number, then it's no solution. If they're all 3 zeros, it's infinitely many. Let's do the next one. Reduced row echelon form. Open parenthesis. 6, 6, -6. 5, 1, 17. And when I type that in, I get a 1, 0, 9 halves, 0, 1, negative 11 halves. And so my ordered pair, again, comes from this last column. And it's positive 9 halves for my x and a negative 11 halves for my y. So it's not, on those first four, it's almost either way can be pretty easy. So you can do it through any of the methods. When you start getting into these other ones where it's 3 variables, the most efficient way is to go into that reduced row echelon form. And so this time, instead of having 2 rows, I have 3, and I have 4 columns. So it's going to look like this: 6, negative 1, 2, 20. Negative 6, 5, negative 4, negative 4. And the last row is negative 1, 2, 3, 21. And when I type that in the calculator, I come up with my matrices having the ones that diagonal again. This time the rows and columns look more like this. And then we have our numbers: 3, 6, 4. So this last column is going to give me my order triplet because it's got 3 variables. So I need 3 numbers: 3, 6, 4. And that's your answer. So on this next one, again, we're going to do reduced row echelon form. Oh, and the only caveat on this is I make double sure that you have all your x's lined up, all your y's lined up, and all your z's lined up, and then the equals, and then the numbers. Because if it's not in that format, or if anything's 0, make sure you include those as 0. So 6, 2, 5, 5, negative 3, 1, negative 5, 1, negative 1, negative 29, 15, negative 2. And then we get our answer. And the answer is 0, 1, 0, 0, 0, 1, 1, negative 3, 4. And so again, our answer comes from this last column. And that column has the answer of, or triplet, 1, negative 3, 4. Again, we have 3 rows, 4 columns. We're going to go ahead and go into the reduced row echelon form. And so, open the parenthesis, the matrices, negative 4, negative 5, negative 4, 5, 3, negative 3, negative 1, 3, negative 1, and 21, 6, 13. Close my matrices and close my parenthesis. And that gives me the matrices with the 1, 0, 0, 0, 1, 0, 0, 0, 1, and negative 3, 1, negative 4. Last column is my answer. And so I have negative 3, 1, negative 4 as my answer. One more. And again, 3 rows, 4 columns. Reduced row echelon form. Open the parenthesis, open this matrices. And I have negative 6, negative 4, negative 1, negative 4, 2, negative 1, 2, negative 2, 2, and then 26, 2, 4. Close my matrice and close my parenthesis. And that matrice, when I type it in, gives me the matrice of the first column, looking like this: 1, 0, 0, 0, 1, 0, 0, 0, 1, and then negative 2, negative 4, negative 1. And so that means this last column is my answers. So my answer is negative 2, comma, negative 4, comma, negative 1. Done.